Okay, so we're going to do the key for the conservation of momentum worksheet. That was for the week of March 1st through 5th. As you can see, I'm just leaving it up so you can see the multiple choice matching definitions. So momentum is D, product of an object's mass and velocity. Elastic collision is E, when objects bounce apart. This actually has been changed on yours. So it actually says when objects bounce apart and kinetic energy is not lost after a collision. That was a typo on my first try. Inelastic collision is A, when objects stick together and kinetic energy is lost after a collision. Conservation of momentum, C, total momentum stays the same before and after a collision. And kinetic energy is B, energy of motion. Okay, so now we're going to do the math. That's the part I really wanted to make sure that we had on video. I'm going to go up. And so remember, it's got a before and after, and then I also am supposed to name the type of collision and the direction they moved. So I'm going to do that through diagramming whatever is happening in this situation. So we're still going to do before and after the collision. So before the collision, we have a 0.035 kilogram bullet striking a 5 kilogram wooden block that is stationary. So that's important. It gets stuck inside the block, and the block and bullet move together at 8.6 meters per second. What is the initial velocity? So that's important, of the bullet. So that's the velocity before the collision. Okay, so now we have our bullet and our wooden block. Our wooden block is stationary and our bullet is moving towards it. So we know it's going to have a positive initial velocity because it is moving towards the stationary wooden block. So we're going to put out our mass and velocity just like normal. The bullet's mass is 0.035 kilograms. And we need to know the initial velocity. We don't know the initial velocity. So that's what we're going to be looking for this time, x meters per second. And then we have the wooden block, which is mass is 5 kilograms, and its velocity is 0 because it is stationary. So that helps us figure that out by giving that a 0 when we solve. After the collision, they stick together. So now we have the bullet that has embedded itself inside the wooden block. That's about as good as you're going to get for that drawing. And it is moving just a tiny bit, but it's going to go in a direction to the right because it's going to go 8.6 meters per second. So we know it's a positive velocity. Since they're together, our masses have to be added together. So 0.035 plus our 5 kilograms, and that's a kilogram here. Don't want to forget my units because remember you can't add unless it's like units. There we go. So now I'm just going to add them together, and it's no trick. It's just 5.035 kilograms of total mass for the two objects. We know the velocity after is 8.6 meters per second. So we have our final velocity already figured out for us. So now we're going to solve. Let's start on the before. We have to do mass times velocity plus mass times velocity. So in this case, we have 0.035 kilograms is our mass times our velocity of x meters per second plus 5 times 0 is 0. So really, on this side, that's all we can do. So I'm just going to bring it back down here because we're going to have to solve for that x. So this is the before. That's where our x is going to be this time because we're looking for initial velocity. Now down here, I do mass times velocity. So 0, not 0 anymore. We added them together. We're using this mass. So 5.035 kilograms times a velocity of 8.6 meters per second. And now that's all I can do. So I have them across. I can solve right here. And I probably should have left this up higher. but I didn't. So it's okay. I'll just bring everything down. So what I want to solve first is over here. I don't have the x. I can solve 5.035, and I'm going to multiply that by 8.6, and that's going to give me 43.301, and that's a kilograms times a meters per second. And I just put all the digits because it wasn't too many. I could have rounded it or dropped off the 1 or something, but I just put it all there so I could just use the whole thing since it's in my calculator already. And then over here, I can't do anything still. So like I said, I should have done this up higher and then brought it down, but I'm just going to drop it down so it's one equation again. Okay, so now I have 0.035 kilograms times x meters per second equals 43.301 kilograms meters per second. So I need to get x by itself. That means I need to divide out the 0.35 on this side. And it's a kilograms. So I'm going to get rid of those. And I have to do that to this side. And it's a kilogram. So kilograms cancel, leaving me with meters per second, which is what I need. Since I already have that number 43.301 plugged into my calculator, I'm just going to hit divided by 0.035, and that's going to give me 1,237, and I'm just going to leave it at that. I'm not going to go any further. Meters per second. That's how fast the bullet was traveling before the collision. Okay, so let's do the next one. So a 20 kilogram or 22 kilogram ball, I don't know if you guys can see it very well, so let me move it up a little bit, is rolling 6.5 meters per second and collides with an 8 kilogram ball moving a negative 5 meters per second. So that's before. Let's set up the before. Okay, so before the collision, we have ball A, we'll say, and we know it's rolling 6.5 meters per second, so it's positive, so it'll be going to the right. It's colliding with ball B, and it's moving negative 5, so that one will be going to the left. So let's go ahead and get our mass and velocity for both of them. So 22 kilograms moving 6.5 meters per second for the first velocity, and then 8 kilograms moving negative 5 meters per second of a velocity. Okay, so now we need to figure out what's happening after the collision. So we have ball A, ball B. It says the 8 kilogram ball moves away at 2.5 meters per second. So the 8 kilogram ball is ball B. So we know that the mass didn't change, but its velocity changed to 2.5 meters per second. And it's positive, so it's going to go to the right. Now, ball A is, okay, you know what I forgot up here, you guys? So I'm going to come back to that in a second. Ball A, forgot to put the type of collision. The mass is still the same, 22 kilograms, and the velocity is what we don't know, so it's going to be x meters per second. Okay, so we're going to find x. Let's set up the problem, mass times velocity plus mass times velocity. And that means we need to do 22 kilograms times 6.5 meters per second plus 8 kilograms times negative 5 meters per second. And I'm going to solve those because we can multiply. Let me get my calculator out. There we go. So we have 22 times 6.5, and that's going to give us 143 kilograms meters per second, plus, now I do the other one, 8 times 5 negative equals negative 40 kilograms meters per second. Now I can add these together because they are like terms, so negative 40 plus 143 equals 103 kilograms meters per second equals. So that's before the collision. Let me make sure y'all can see. There we go. Okay, let's get the after the collision. So 22 kilograms times x meters per second plus 8 kilograms times 2.5 meters per second. Right, so the only thing I can do on this side is 8 times 2.5. So I'm going to do 8 times 2.5, and I'm going to get 20 kilograms meters per second. And down here, I can't do anything. So now I'm looking, nothing can be done here because I'm looking for x, nothing here. So I'm just going to drop it down on the other side of the equal sign so I can make one long equation. Okay, so now we have to look for like terms. So we're ready to start solving for x. We need x by itself. We got to get rid of 22 and 20. The only way to start is get rid of the kilograms meters per second that match the term kilograms meters per second over here. Since we're adding 20, we're going to do the opposite. Subtract 20 kilograms meters per second. That cancels that. That means I have to do it over here. So 103 minus 20 is going to equal 83 kilograms meters per second. I'm writing really small now. And then now I have to drop down the 22 kilograms times x meters per second. So I have to get x alone still by getting rid of 22. Since it's being multiplied, I do the opposite, which is dividing. Oop, don't know why I wrote a 3 there. Let's do a 2. 22 kilograms. So that cancels out, leaving x alone. Got to do it to this side. 22 kilograms. Kilograms cancel, leaving me meters per second. So now I'm going to do 83 minus 22. I'm sorry, not minus. Let's try that again. 83 divided by 22 equals 3.77. So I'm going to put it over here because I'm out of space. 3.77 meters per second. And I'm going to circle it. Now, I need to tell you, we didn't say the type of the collision above there, but we're going to do it. But let's start with this one first. Name the type of collision. They bounced apart, so we know that that's going to be an elastic collision. And it also says, tell me the direction it moved after the collision. So in my diagram, it's showing the direction. So since it's a positive, I know that it's moving to the right as well. So ball A followed ball B. It's such a heavy ball that when it knocked ball B away, being a lighter ball, it followed it, okay, at 3.77 meters per second. So let's look up here. We forgot to say the type of collision. We said the direction, so we're good, it's going to the right. But the type of collision, if they stuck together, is inelastic. Okay, so I can't forget to tell that because you will have to know the types of collisions when you take the test eventually. Okay, so the next thing we need to do is change the page so we can do the next problems. And I'm going to move it all up so y'all can see. Everything's crooked. I'm realizing as I'm looking at my screen and looking at what I'm seeing that you guys might see crooked stuff. So I want to make sure that's not happening. Okay. We are going to now do number 3. A 3 kilogram ball is heading 10 meters per second. Okay, I'm going to stick a piece of paper under here my table is kind of bumpy, and so if I don't have another piece of paper, it's really hard to write. Okay, so another ball that is stationary. After the collision, the 3 kilogram ball moves at 2 meters per second. The other ball moves at 12 meters per second. What is the mass of the second ball? Okay, and we have to name the type of collision as well. So again, before and after. So we need ball A and ball B. So 3 kilogram ball is the mass and the velocity is 10 meters per second positive, so it's going to the right. Ball B is stationary, has a mass of, we don't know, so it's going to be x kilograms. And it has a velocity of 0 because it is stationary. So just like the entry test we did earlier. So after the collision, we have A and B. The 3 kilogram ball, so we know that's A, so mass is 3 kilograms, moves at 2 meters per second to the right because it's positive, so its velocity is 2 meters per second. Ball B, okay, the other ball, we don't know the mass, so it's X kilograms. It moves away at 12 meters per second, and it is a positive, so it's moving to the right. So now we need to solve for X, finding mass. Okay, so we're going to do the same process, mass times velocity plus mass times velocity. So 3 kilograms times 10 meters per second plus X kilograms times 0, which is going to be 0. So 3 times 10 is 30 kilograms meters per second plus 0. And then we know that's just going to be 30 kilograms meters per second equals. Okay, so I can just not worry about the 0. I moved it up here because I didn't want to run out of space. All right, on this side, 3 kilograms times 2 meters per second plus X kilograms times 12 meters per second. And 3 times 2, I can do that. 6 kilograms meters per second. Whoa, not plus. Meters per second plus X kilograms times 12 meters per second. So looking at this, I can't do anything. Okay, I have to move it down. Just going to put it down here so I can make one long equation and I can solve for X. All right, so I look at this, I got to get rid of the like terms again. So I have meters per second, kilograms, kilograms meters per second, and kilograms meters per second. That means I can get rid of this one first because we're trying to get X by itself. This 6 kilograms meters per second is being, basically it's positive, so it's like added in the equation, but we're going to subtract it out. So we're going to do the opposite. So that cancels, which also means we need to subtract 6 kilograms meters per second here. So 30 minus 6 is 24 kilograms meters per second equals, we still have our X kilograms times our 12 meters per second to deal with. Okay, now we need to get rid of the 12 to get X by itself. I have to divide it out. So meters per second cancel, leaving me with kilograms. That's what I'm looking for. 24 divided by 12 is 2 kilograms. And the type of collision, they bounced away from each other. It's going to be an elastic collision. Elastic. I'll put it in a box so we all can see it. Okay, a 6 kilogram magnet is sliding at 18 meters per second toward an 18 kilogram magnet moving negative 24 meters per second. Well, they're magnets, so they're going to stick together and move after the collision. What is their new velocity together? So the new velocity is what we're looking for after they stick. So before and after, we've got a magnet and another magnet. So this first one's got a mass of 6 kilograms and is moving 18 meters per second. So velocity of 18 meters per second. The second magnet has a mass of 18 kilograms and it's moving a velocity of negative 24 meters per second. So they're going at each other like that. So positive velocity, negative velocity makes our direction. After the collision, they stick together and we need to know which direction they're going after. So we know our mass is going to be added together because they become one object after. So 6 kilograms plus 18 kilograms equals 24 kilograms of mass. The velocity we do not know. That's going to be X meters per second. So let's solve. Mass times velocity plus mass times velocity. So 6 kilograms times 18 meters per second plus 18 kilograms times negative 24 meters per second. So now I have to do 6 times 18. And that's 108 kilograms meters per second plus 18 times negative 24 equals negative 432 kilograms meters per second. So now I can add those together. So I already have negative 432 plugged in, so I'm just going to say plus 108 equals negative 324 kilograms meters per second equals. So that's the before. So now I need to do the after. Well, I already know that I have 24 kilograms of mass and an x for my velocity, so there's not much I can do. So I'm just going to move it down here, mass times velocity, 24 kilograms times x meters per second. So now I have it all in one line. I can set it up and solve for x. So remember, I have to get rid of my 24 kilograms to get x by itself. So I divide it out. And if I do that to one side, I got to do it to the other. Cancels kilograms, leaves me with meters per second. So I'm going to have negative 324 divided by 24 equals negative 13.5. And that unit is meters per second after the collision. So they stuck together. So remember, when we stick together, we're making an inelastic collision. Okay, that is it.